Hi, hello everyone. Welcome back to Akki-Vikki Math. This is Akshaya, 6th grade. Let us solve this problem today, which has appeared in RMO. Let ABCD be a unit square. Draw a quadrant of a circle with A as center and B, D as endpoints of the arc. So ABCD is a unit square, which means the length of this side of the square is equal to 1. Let us put AB equal to 1. AB equal to 1, BC equal to 1, CD equal to 1 and AD equal to 1. And they're said to draw a quadrant of a circle, which means a quarter circle, with A as center of the full circle and B and D as the endpoints of that quarter circle. And similarly, draw a quadrant of a circle with B as center and A, C as endpoints of the arc. We have to draw another quarter circle with B as center of the full circle and A, C as the endpoints of that quarter circle. So these are the quarter circles. Inscribe a circle touching the arcs AC and BD both externally. So this is the arc AC and this is the arc BD, and this circle is touching these both arcs externally, and also touching the side CD, which means this circle the side CD is tangent to this circle. So now we have to find the radius of this circle. First, let us put the center and let us put the center. Okay, let this be the center. That is the center. And now we have to draw the radius from O to CD because it makes the angle 90. Let us draw the radius from O to CD. From O to CD like this. The angle between them is 90 because CD is tangent to it. And now let this point be some E. Let this point be E. Now can we say E is the midpoint? Let us find out if E is the midpoint of CD. So for that, let us draw OC and OD. Let us draw OC and OD. This is OD and this is OC. OC. And now, if we can say OC and OD are equal, then we can say that E is the midpoint because it is the altitude of the triangle OCD. If it's an isosceles triangle, but we cannot directly say that OC equal to OD. So let us draw OA and OB and let us see what they are equal to. Let us see what their lengths are first. Let us draw OA and OB. OA, this is OA and OB. OB. Okay, wait. Okay, the OA and OB. This is OA, OB. Okay, and let this point be some F. Let this be G. And now let's find what OA and OB are equal to. So now OA equal to, this is OA, which is also equal to AF plus OF. AF plus OF. And we have AF. This is AF, which is in the quarter circle with the arc BD, we have the radius of the full circle, including the center A. We have the radius equal to AB or AD, which also have the length 1. And AF is nothing but the radius because F is the point on the circumference of that circle. So you can just say AF is the radius, which is equal to 1. 1 plus OF, the radius of this small circle. Let it be some R. Let us label it R. R. And now OB. Similarly, we have OB equal to GB plus OG. GB plus OG. OG. And now we have GB. We have the circle, the arc AC, including the circle with center B. We have the radius of that circle is BC or BA, which is equal to 1. And we want to find BG. G is also lying on the circumference of the circle with center B. So we can say BG is also the radius, which is equal to 1. 1 plus, one moment, let us erase this. 1 plus, and we have OG. OG is the radius of the small circle, which we have assumed R. And now we have OA equal to 1 plus R, OB equal to 1 plus R, which means these both are equal. So we can say OAB is an isosceles triangle. And let us draw the altitude, which is also the perpendicular bisector of from O to AB. The altitude is also the perpendicular bisector of the side AB. Let us draw that first. From O to AB. And since it's a perpendicular bisector, first let us label this point H. And this angle will be 90 since it's the altitude. And since it is a perpendicular bisector, H is also the midpoint of AB. So we can say these both are equal. And we have these both as AH equal to 1 by 2. This is equal to 1 by 2. Similarly, BH is also equal to 1 by 2. And now we have 1 by 2. Let us find what OH equal to. Here this angle 90. Over here we have CBH is also 90 because of the square. And we will take lines OH and CB. If AB is the transverse line for both of them, then we have sum of the internal angles sum up to 180. It is summing up to 180. So we can just say OH is parallel to CB. These both lines are parallel, and if we extend this OH, it will go to OE because that makes an angle 90, and we have these both lines are parallel. We have 90, 90. So again, we can say HE is parallel to BC, and we have EC is parallel to HB because they both are lying on, EC is lying on CD, and HB is lying on AB, and CD and AB are parallel because it is a square. So we can say CEHB. CEHB is a parallelogram. And since the all angles in this parallelogram are 90, we can just say it is a rectangle. We can just say it is also equal to rectangle. And because it is a rectangle, the opposite sides are equal, and we have BC equal to 1. So we can say EH is also equal to 1. EH equal to 1, and we know OH equal to, we want OH, right? So OH equal to HE minus OE. This is also equal to, we have HE right now, it is equal to 1 minus OE is the radius of this small circle which we assumed R. R. Now we have the length of OH equal to 1 minus R with the length of AH equal to 1 by 2. So, and we also have OA equal to 1 plus R. So, in the triangle OAH, by the Pythagorean theorem, since it's a right angle triangle, we can write, so by the Pythagorean theorem, we can write OA square equal to OH square plus AH square. OH square plus AH square. And we know the length of all three sides. So OA equal to 1 plus R, which means 1 plus R whole square equal to OH equal to 1 minus R. 1 minus R whole square plus AH 1 by 2. 1 by 2 whole square, which is 1 by 4. Let's write 1 by 2 whole square only. And let us simplify this. Let us expand these both squares. Now 1 plus R. 1 plus 2R plus R square equal to 1 minus 2R plus R square plus 1 by 4. And let us take this whole equation to this side, and we can also cancel 1 because it is a constant. Let us take this whole equation to this side, and we can write 0 equal to minus 2R plus R square plus 1 by 4 minus 2R minus R square. And we have over here plus R square minus R square. So we can just cancel these both. And we have, this is equal to minus 2R minus 2R minus 4R plus 1 by 4, which is 0. This is 0. So we can write 4R equal to 1 by 4, which means R equal to, by cross multiplying, R equal to 1 by 16. R equal to 1 by 16. Hence the radius of the circle is 1 by 16. Okay. Now the concepts we have used in this question. Are first, isosceles triangles. First, isosceles triangle. Isosceles triangle. And second, parallelogram. Third, rectangle. And fourth, rectangle. Fourth, Pythagorean theorem. Pythagorean theorem. So we have used all these concepts in this question. Okay? For better understanding and practice on these concepts, follow our classes The link is in the description below. And don't forget to like, share and subscribe. Bye bye.